Welcome to video 2 on PB2, multi-stage events and applications of probability. Let's dig back into our probability toolkit. In this video, we'll tighten our grip on the fundamental counting principle. To calculate the probability of an event occurring, we need to know the total number of possible outcomes. For multi-stage events, it is often impractical to list all possible outcomes using tree diagrams, as the total number of possibilities is simply too large. By using the fundamental counting principle, we can easily determine the number of all possible outcomes. The fundamental counting principle states that the total number of ways that a succession of choices can be made is found by multiplying the number of ways each choice can be made. Algebraically, we can say that if event A has A outcomes and event B has B outcomes, then A and B together have A times B outcomes. If there are more than two events, then we simply continue to multiply the number of possibilities together. So if A has A outcomes, B has B outcomes, C has C outcomes, and so on, then A, B, C, etc. together have A times B times C times, and we continue to multiply those outcomes together. Common topics for these types of questions include number plates on cars, poker machines, combination locks, passwords, personal identification numbers. More on these to come. Let's look at an example. A travel agency offers Queensland holiday packages flying with Qantas or Virgin Blue, travelling in first, business or economy class to Brisbane, the Gold Coast, the Great Barrier Reef or Cairns for periods of 7, 10 or 14 days. How many holiday packages does the traveller have to choose from? Organising this information into a table, we can see that 2 airlines with 3 classes of tickets, 4 destinations and 3 different lengths of a holiday. Multiplying these together gives us the number of packages. So we have 2 multiplied by 3 multiplied by 4 multiplied by 3. 2 times 3 is 6. 6 multiplied by 4 is 24. And 24 multiplied by 3 is 72. So there are 72 different packages. Another example. Mobile phone numbers in Australia have 10 digits and start with 04. How many possible numbers are there? Let's think about the numbers. In the first spot, there is one possible number, a 0. There is only one possible number for the second digit too, a 4. The remaining 8 digits can be formed by any of the 10 digits 0 through to 9. That gives us a total of 1 multiplied by 1 multiplied by 10 times 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 10, which gives us 1 times 10 to the power of 8, which is 100 million different possibilities that can be issued in Australia. When numbers were first allocated, each mobile phone provider was issued with sets of numbers. That meant that it was possible to tell what provider someone was with by looking at their number. Now that people can keep their numbers when they swap providers, it isn't so easy. Just for interest's sake, this table shows the list of countries by number of mobile phones in use. Australia comes in at number 38, but there are almost 8 million more mobile phones than there are people. There are a number of countries like that, with Russia being almost 2 mobile phones per their 142 million residents. China is the largest, with 93.2% of their 1.4 billion citizens using mobile phones. To accommodate for this, mobile numbers in China are 11 digits long, with just the first digit being common. All numbers there start with a 1, giving them 10 billion different phone numbers. I wonder how long it will be before they are all used. That completes video 2, looking at the fundamental counting principle. See you again in the next one.